First of all, I'm going to add this compound. It has a funny name. It's called phenolphthalein. Chemistry is full of crazy names.
Yes.
And you guys are going to learn. It's really beautiful. Girls love my classes in grade 12 for organic chemistry. Because they do. They love naming compounds and finding the rules. Why that this compound is named like that. And I'm going to add a few drops, maybe 5, 2, 3, 4, 5,
What is
6.
it?
It's a compound called pH indicator. You guys learn about pH a little bit?
Not so much.
Not so much.
Ben says grade 5.
You guys know that substances sometimes can be acidic, but the opposite of acidic. Basic. So when it's acidic, it's like if you have heartburn in your stomach, it's acidic. If you have a food that is full of fats, sometimes we feel burning in the stomach, right? And you have to take some pills to get rid of the heartburn. Normally they give you calcium carbonate or Tums, right? So this compound, if I were to swallow it, it would burn me because it's an acid, it's very strong. It won't kill me because it's a weak acid. That's why we put it in vinegar with olive oil and make salad dressing, right? So I put this compound that changes color depending on the pH. Right now, it has no color, it's clear. But if I add a little bit of a base, this is a base. Compounds that are base are corrosive. This is not highly concentrated, but if you had it in my chemistry lab, my students always wear gloves for safety reasons because you don't want to put it on your skin. It will not kill me, but it will make my skin yellow. So I get yellow marks on my skin, and it takes a while to get rid of it. But I'm going to take a little bit of that one carefully and add it. And then you guys are going to see if something happens here. Have you seen anything that happened when I dropped it? But you see, look at what happened when I stir. It's the magic show. It disappears. It's there and it's gone. It's there and it's a nice, what color is that? Nice pink. Yeah. So I do it with a tornado, but I forgot my stirring plate. So on a stirring plate, I put here a stirring pad, a magnetic part, and it makes a little tornado. So I don't have, but I have to do it with my hand. I have to shake, stir it. Some more. And then hopefully there's a moment that the color stays and it doesn't disappear. When that happens, it means the acid neutralized the base. So the concentrations are the same. And we have what is called neutral pH. Water is neutral, right? Water has a pH, pure water has a pH of 7. Acids have a low pH close to 0.11. And bases like Windex or ammonia. They have detergent, it's also very basic. You wash your clothes in something that is basic. Still, it'll dissipate and disappear eventually by itself. But I want you to see if we can actually get to a point that it stays. Yeah, almost. You're going to have to add more.
What creates the color?
The interesting question. What creates the color is this compound changes configuration. So the structure, the atoms move, takes a different configuration and changes color. So it's the dye or the indicator. That's why it's changing color. You can use it with cabbage juice. Cabbage juice is also a good indicator because cabbage juice, you boil cabbage at home, you make a juice out of it, and add it to acids and bases, and it changes color depending on the solution where it's found. I'm going to have to add tons in here because it's concentrated. You think it's going to stay?
Oh.
Look, almost.
Whoa.
Because then it gets too strong to actually reach the point when the base neutralizes. See, this is a good point. When the base neutralizes, the acid is pink. Do you think I can make it clear?
Yeah.
What would I have to do?
Add
So let's add acid. And this one is going to go quick.
Does it always change the paint?
Yes. There's other indicator. This one is for a specific
Oh.
symptom.